Fundamentals of Engineering Electromagnetics, Ching PDF download. This book was designed to use an undergraduate text in engineering electromagnetics. Electromagnetics is one of the most important subjects of the electrical engineering curriculum. Understanding the laws governing magnetic and electric fields is vital to understanding the fundamentals of the functioning of electric and magnetic devices and machines. Additionally, understanding the fundamental theories of electromagnetic waves is essential for understanding the action at a distance electromagnetic phenomena and systems. Since most electromagnetic variables are the function of three-dimensional space coordinates and times, electromagnetics is more complicated than electric circuit theory. A thorough understanding typically will require a series of 2-semester courses or 3 courses within quarters. However, some electrical engineering programs don't schedule this many hours for electromagnetics. Purpose of the ebook Fundamentals of Engineering Electromagnetics. The book aims to address the need for an educational resource that quickly covers the fundamentals of electromagnetism easily and clearly, but also covers crucial engineering application topics like electric motors, transmission lines, waveguides, antenna arrays, antennas, and radar systems. I believe this is among the main issues that students face in studying electromagnetics, their inability to grasp the concept behind being able to understand an electromagnetic concept. The conventional inductive approach of starting with experiments and then gradually synthesizing the laws into Maxwell's equations tend to be a bit fragmented and not cohesive. The introduction of the gradient, divergence, and curl operations is thought to be unintentional and random. However, the extreme of beginning with the complete set of Maxwell's extremely complex equations, as fundamental postulates, is likely to provoke confusion and discontent in students from the beginning. The issue of the necessity and the sufficiency in these equations isn't considered, and the idea for the electromagnetic model remains undefined. Contribution of the ebook to engineering. This book develops the electromagnetic model by using an axiomatic method by dividing the model into steps. First to study static electrical fields, followed by static magnetic fields, and finally, for a field that changes over time, which leads to Maxwell's equations. The mathematical foundation of every step is Helmholtz's theory, which says that a vector field can be measured to be within an additive constant when both its divergence and curl are all specified. The physical basis for this theory could come from the notion that the difference in the strength of a field vector is an indicator of the strength of the flow source and the curvature of the field an indication of the strength of the vortex source. It is determined if the strengths of the flow source and vortex source are defined in the vector field. To construct the electrostatic model for free space, it is required to define the single vector, namely the intensity of the electric field, by defining its curvature and divergence as postulates. The rest of the electrostatic relations and free space, such as Gauss's and Coulomb's laws, are derived from these two simple postulates. The relationships in materials can be constructed using the idea of similar charge distributions. For dielectrics with polarization. Similar to the model of magnetostatics of free space, it is essential to specify a singular magnetic flux density vector, B, delineating its divergence and curvature as postulated. All other formulas are derived from these two concepts. The notion of equivalent current density formulates the relationships in materials. The value of these postulates is in their ability to give results that correspond to evidence from experiments. In the time-varying fields, both magnetic and electric field intensities are correlated. Overview of the chapters. Chapter 01. It gives some reasons to study electromagnetism. The book also introduces the sources of the functions and the fundamental field quantity, as well as 3 constants universal, to define open space within the electromagnetic model. Chapter 02. This chapter covers the basics of vector algebra and calculus and the relationship between Cartesian, cylindrical, and spherical coordinate systems. Chapter 03. It discusses the fundamental principles and techniques for solving electrostatic challenges. Chapter 04. This chapter